Good afternoon, this is Professor Elliott, and in this lesson we are going to convert a truth table output into a logic gate circuit. So this is a fairly simple example just to illustrate the point. So we have three input variables, A, B, and C, and you can see them counting there from 0 through 7. So let's call the output X, and that'll be the output. And let's put a logic 1 in the output for each condition which you want the output to be true. Okay, so let's do this one. Let's do this one. Let's do this one. And let's do this one. Okay, so that means then the other states the output is going to be low. So what we want to do is to write the equation for each input condition where the output is active. Now I'm just picking the output active as high. We could easily design the circuit for the zeros instead of the ones, but we're just doing the ones today. Okay, so anyway, so once I get started, I think you'll see what I'm doing. Okay, so the output will be true if we have A naught, right, ended with B naught, ended with C naught, right, or we have A naught ended with B, ended with C naught. So each of these equations is describing the exact input conditions in order to make the output true. Okay, and the next one is going to be A ended with not B, ended with not C, and then finally we have A ended with B, ended with C naught. Okay, just double check. Okay, good. So this is called I'm sure you read this somewhere before. This is called a sum of products form. So a truth table gives us groups of terms ANDed together, and then those terms are ORed. So it's a sum, which means OR, products, which means ANDed. So sum of products form. You always get this when you're using a truth table in this manner. Okay, so continue on. Okay, so our next step is to construct the gate circuit. So let me just write out the equation, just so we have it for reference. So we had X equal, and we're not going to simplify this. We're just going to draw the circuit. Yeah. Okay, that's one term. ORed with A naught B C naught. ORed with A naught B naught C ORed with A B. All right. Okay, so that's the equations, the final equation that we arrived at. Okay, so let's just sketch this. So we need, and I'm not going to simplify this, so we're just going to draw it as is. Okay, so we need, and it's probably going to be a little bit messy, so but I apologize for that. So we have A, right? And then we're going to need an inverter to give us A naught. And then we need B. And an inverter. So we're going to need B naught a couple times. And then we're going to need C. And then an inverter. Like that. Yeah. See a little. Okay. All right, so we need to AND these terms together to do to give us that. So let me I'm just going to extend this down. Give ourselves maybe not quite that much here. All right, so let's go. Yeah. Okay, I'll shorten this down a little bit. Like that. Okay, so that would be A naught ANDed with B. ANDed with C naught. Okay, so that should be, we have A naught ANDed with B naught ANDed with C naught. Okay, so that would be the output right at the end of that final AND gate. Okay, so now we need A naught, and I'm going to use a different color. Let's do it black. So we need A naught ANDed with B, and there was, okay, so right. Okay, so that's going to be the C naught ANDed with B, it'll be right there, and then we'll pick up the A. Okay, like that, and then we just need the A naught. Okay, so we already have that one. there. Okay, so we've done, just change the color here. Okay, so we have this here, right, which is going to be there, and we have this one here, A naught, which is going to be, and then we have, yep, looks okay. Okay, so now we need, okay, so let's go back, and let's use purple. So now we need B naught ended with C. So we need B naught ended with C naught. Okay, so let's bring down like that, like that, like that, and then we need C naught. Oh, sorry, B naught, which will be right. Okay, so we have B naught, and then it was C naught. Okay, bring a line, and we just need to pick up A. Right. So that's going to be A naught, and A ended with B naught ended with C naught. So we have A, and we have B naught, and we have C naught, and that's going to appear down there. And can I squeeze this on? So we have B ended with C naught. Right. So we already have. So we need. I need. No, sorry. Oops. Here, I want to use a different color. Let's use. I don't know. Let's use this orange. Okay. So we need this term here, which we already did there. So that appears right there, so we don't have to recreate that. So we just really need to, okay, put a tap off here. I'm just going to squeeze this in. Like that. And we have A. Okay, so let's go and change that. So that's going to be this. Okay, so I'm just going to pause the presentation. When I go back and and just check to make sure we're okay. I think we are. I'll be back in a minute. All right. Thank you. Okay, so it all looks okay. So I'm gonna have to go to the next slide. So all I want to do is just we're just gonna bring over each of these outputs over to the next slide, and let's do that in black. Okay, so we have those 4 outputs we're going to carry forward and add a new slide. Okay, now because we only have 2 input gates in our chip in our kit, so I'm doing everything with 2 input gates. Of course, you can buy them with more inputs, but anyway, that's how we're doing it. Okay, so we have one line comes in like that, another one comes in like that. Okay, then ORed. Like that. Okay, and then we need one more. Do over. Okay, so those 4 inputs continue on over here. So we need a one of these, one of these, one of these, and I think it's green. Yeah. Okay, so these are the OR gates, and this is our final output. So this is summing all the product terms, and hopefully you can see how those connect together. So okay, so thanks for your time, and we'll catch you next time around. Okay, cheers.